Hello, my name is Mariana Menchero. I'm a senior forecaster at nixtlar, and today I want to talk to you about TimeGPT and nixtlar. I want to show you how you can leverage generative AI for time series forecasting in R. nixtlar is an R package that I developed that brings the power of TimeGPT, the first foundation model for time series forecasting, to the R community. With nixtlar, you can gain access to a state-of-the-art forecasting model with no additional training required. nixtlar is already available on CRAN, so you can easily install it and integrate it into your forecasting workflows. And well, let's do a deep dive. TimeGPT, as I said, is a foundation model and it was developed by nixtlar for time series forecasting and anomaly detection. It is currently available in Python through nixtlar, a Python library. In general, foundation models like TimeGPT use something called transfer learning. They're trained on large, diverse datasets and can generalize to different contexts. This means they can forecast on unseen datasets without additional training. And so they represent a new paradigm for time series analysis and forecasting. TimeGPT, in particular, is a transformer-based probabilistic model with self-attention mechanism. It takes a window of historical values, like tokens in text, and then predicts what comes next. The TimeGPT architecture consists of an encoder-decoder structure, like this one, with multiple layers, each with residual connections and layer normalization. A final layer maps the decoder's output to the forecasting window dimension. Now, TimeGPT was trained on a huge collection of publicly available time series data, with over 100 billion observations from different domains such as retail, energy, finance, demographics, healthcare, Internet of Things, and many more. This dataset included time series with different seasonalities, such as hourly, daily, monthly, quarterly, yearly, and different trends. Some were increasing, some were decreasing, some series didn't have any discernible trends. Some series have very clear patterns, while others have a lot more noise. And some of them contain unusual observations or outliers. And it's this diversity that helps TimeGPT handle a wide range of scenarios and forecast unseen time series accurately without additional training. As I said, TimeGPT was the first foundation model for time series forecasting, and after its release, other models follow, including Llama, TimesFM, Chronos, Moment, and some others. And what do they all have in common? Well, besides being foundation models, none are available in R. Until nixtlar. I developed nixtlar to make TimeGPT easily accessible to the R community. To showcase how nixtlar R works, let's use some real data. I decided to use the Corporación Favorita forecasting competition, which took place in Kegel a few years ago. So let's imagine you're the manager of a Corporación Favorita store, a grocery chain in Ecuador. You're responsible for forecasting the sales of all products at your store for the next 2 weeks. You have daily sales data for each product. For some, you have years' worth of data, while for others, only a few weeks. To make things interesting, let's say that you need to forecast as soon as possible to start placing your orders and getting your inventory on time. As an R programmer, you decide to put nixtlar to the test. And for comparison, you will also forecast sales using the ARIMA and ETS models from Fable, along with Profit, also the Fable version. As a baseline, you will use a seasonal naive forecast. So let's go to RStudio. nixtlar is already on CRAN, so you can install it from there, and just make sure that you have the latest version that at the time of this video is 0.6.2. I'm also gonna load data table and tidyverse to load the data and do some data transformations. The data corresponds to one store from the Corporación Favorita dataset, more specifically store 44, and it looks like this. I didn't know data pre-processing. I just put the data in this format. That is the format that nixtlar requires. There are two required columns, one with timestamps and another with the target value. The column with the timestamps has a default name DS and must contain timestamps in this format: year, month, date, or year, month, date, hour, minute, and second, either as characters or date objects. So I'm just going to convert these values to dates. The target variable has numerical values and the default name is Y. And since in this case we have multiple products, we need an additional column with a unique identifier for each of the series. The default name is unique ID, and it can contain integers or strings. And to be able to compare the results of nixtlar with the other forecasting models, let's separate the data into a train and a test set. We're going to forecast a 14-day horizon, so we're just going to leave the last 14 observations for testing. And well, here you can see that we have 3,633 time series. Before doing any forecasting, it is very useful to visualize the data, and nixtlar has a function for that. It's called nixtlar client plot, and you simply pass the datasets. And well, here's the data. To get started with nixtlar, you first need to set up your API key. The API key is a unique string of characters that is going to be used to authenticate your request to the TimeGPT API. If you don't have yours, please go to dashboard.nixtlar.io and you will get yours. Now, to set it up, you can use the nixtlar client setup function. You just place your API key here. And well, although this method is very easy, is the least secure and is not permanent. If you restart your R session, then you're gonna need to set up your key again. More secure and permanent ways are using environment variables, either with options or editing your R environment directly. Our documentation contains a vignette that explains all of these methods, their benefits and drawbacks in more detail, so please check it out. There's also a function to validate the API key. You don't have to do this every time you want to use nixtlar. We're gonna use it this one time, so you can see that the key that I have is already valid. And well, now we're ready to start forecasting. To generate a forecast, use the nixtlar client forecast function. Simply pass it the dataset with the input and select the forecast horizon. If you don't specify the frequency of your data, then nixtlar is going to try to infer it. In this case, well, it's daily data. And as before, we can plot the results using the nixtlar client plot function. So here we are. Now, you probably note that there's a warning message. Since we're trying to forecast 14 days, which exceeds the frequency of the data, I mean the seasonal periods of the data, which for daily is 7, it is recommended to use the TimeGPT long horizon model. You again use the nixtlar client forecast function and you simply specify that model. The TimeGPT long horizon model is very well suited when you try to forecast more than the seasonality of your data. So if you have monthly data, for example, and you want to forecast more than 12 months, then please use this model. Likewise, if you have quarterly data and you need more than 4 quarters, then use the long horizon model. And once it's done, as before, we're going to use the nixtlar client plot function to plot the results. Now it's done, and here are the results. And well, now that we have both of our models, we're gonna compare its accuracy using the mean average error and the mean absolute scale error with the accuracy of other well-known and widely used forecasting models in R. So, well, these are the results. Just as a summary, we want to forecast the next 14 days of sales for 3,633 products, and we're using out-of-the-box implementations for TimeGPT via nixtlar, ARIMA, ETS, and the seasonal naive, which we're going to use as a baseline via Fable, and Prophet via Fable Prophet. Since the seasonal naive is the baseline, we're going to consider the relative execution time. That's why this seasonal naive has a 1, and the others are simply the total execution time divided by the time of the baseline. So, for example, this result is telling us that TimeGPT took less than the seasonal naive. If we use the mean average error, the model with the best accuracy is the TimeGPT long horizon. And if we use the mean average scale error, the ARIMA has the best accuracy, but please note the difference in time. ARIMA takes 293 times longer than the seasonal naive, while the TimeGPT long horizon, which has the best accuracy with this metric of the two, it just takes 1.97 times what the seasonal naive. So it is almost or it's very similar accuracy with a fraction of the time. Now, nixtlar also provides access to TimeGPT's features and capabilities, such as fine-tuning. This means that you can train the model using your own datasets to try to improve performance. You can also add exogenous variables if you have them. For example, if you have promotions, holidays, or special events that you think they can help you predict your target variable. You can use a custom loss function that will allow you to tailor the fine-tune process to meet specific performance metrics. You can use prediction intervals or quantiles to quantify the uncertainty of the predictions, because in this example we only use a point forecast. And finally, you can also use Azure. In Azure, TimeGPT is called TimeGen, and you can use TimeGen via nixtlar. There's a vignette explaining how to do this. It's very easy. You just need to specify, in addition to your API key, a base URL. And well, just so you can see how easy it is. For example, if you want to add prediction intervals, then you just simply use the level argument. Let's say you want to generate the 80% and 95% prediction intervals, and as before, once this is done, you can plot the results using the nixtlar client plot function. That in this case will also include the prediction intervals. And there's even more. TimeGPT can also be used for anomaly detection and cross-validation. Let me go back to our studio. To detect anomalies, use the nixtlar client detect anomalies function. Here I already loaded the results, and they look like this. TimeGPT uses prediction intervals, and all the observations that fall outside of those intervals are considered anomalies. By default, TimeGPT uses a 99% prediction interval, but if you want to change that, say to a 95%, simply use the level argument. And if you just want to see which observations are anomalies, then filter by anomaly equal to true. You can use the plot function, setting plot anomalies equal to true. And here you can see all the observations that are anomalies. For example, all of these dots that correspond to these observations are being considered an anomaly using a 99% prediction interval. You can also use cross-validation. That is a method for evaluating the performance of a model. To use it, use the nixtlar client cross-validation function. Here we need to pass the training data. And you need to choose two important arguments, the number of windows and the step size. So I think it's better if we plot the results first. So what the cross-validation function is doing is using all of this data up to the first orange dotted line to try to predict this segment. And then it's going to use all the data up to the second dotted line and predict this other segment. And finally, since we pick three windows, it's going to use all of this data to predict the last 7 observations. And the step size here is the number of steps you move forward. So between these dotted lines, there's 7 days. You don't have to do anything in the plot function. If you pass an output with cross-validation results, it's going to automatically create these lines. And well, as you can see, nixtlar brings TimeGPT, the first foundation model for time series forecasting, to the R community, making advanced forecasting capabilities accessible and user-friendly. TimeGPT has shown that it can perform well-known and widely used forecasting models in R, offering comparable accuracy in a fraction of the time. And there are some additional features available through nixtlar R that can help you refine and improve the accuracy of your forecast. So please explore nixtlar R and see how TimeGPT performs on your own datasets. We have extensive documentation and vignettes here. And well, if you like nixtlar R and find it useful for your own projects, please give us a star on GitHub. Thank you very much, and I'll see you next time. Bye.